For today's Leet Code problem, we are going to solve the two-sum problem. The problem is that given an array of integers nums and an integer target, return the indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So already the problem is giving us a couple of caveats and a couple of helpful hints. So before we get started in solving on this problem, our objective for this problem is to be able to find two numbers that add up to the target. The two numbers have to be different numbers. They cannot be the same numbers. And that is really the only caveats that we have for this problem. So for the objective of this video, what I want to do is one, be able to solve this problem, but two, also be able to talk about how we're going to be using a dictionary to find the solution that is going to be helpful for us in making sure that our code is as efficient as possible. So if we're talking about dictionaries, we have key value pairs that a dictionary is going to be holding. And what I want to use the dictionary for today is to be able to hold the numbers that we are going to be trying to add up together to make a solution, specifically the target, and the values within the list will be stored in the keys, and then the indices of where those values are would be stored in the values portion of the dictionary. So I'm going to be iterating through, and as I iterate through these numbers, I'm worried about two things: the value that I am currently iterating through and the difference of what would be able to make the target with the addition of the number that I'm looking at. So the two numbers that I'm really going to be looking for are the difference, which is the target minus the number that I am looking at, and then the number itself as well. So taking a look at the first example, we have our first number 2. So the difference between 2 to the target is 7. I look to see if 7 is within the dictionary, because if there is a 7 already in the dictionary, I found my answer. I have 2. There's a 7 in the dictionary that would make my target. I would be able to have found my solution, and I will be able to return the two indices. But the difference of 2 to target of 9 does not exist. 7 does not exist. So what I'm going to do is I'm going to store the number and the index that it's stored in. And that way, if I find another number where that number's difference happens to be 2, I am able to return the indices of the component that is going to be adding up to the target. The next number that I'm looking at is going to be 7. The difference between 7 to the target is 2. I check to see if the difference exists. I see that the difference does exist. 2 does exist within the dictionary. I have found my counterpart to 7. So I return the value of the index that 2 is in, which is 0. And then I know that index 1 because I have already I know the index of 7 because that's the number that I'm currently iterating through. That's how I end up with 0, 1. Let's take another example where we have the problem doesn't immediately solve itself. So we have another array of 3, 2, and 4. The target is 6. In this situation, you could almost say, hey, 3, the first number of 3, if I can add it up twice, that would get to the target. But remember that the problem has this caveat of you may not use the same element twice. They have to be different values. So we set up the dictionary again of key value pairs. We iterate through the first number, 3. I look for a difference. 6 minus 3 is 3. The difference does not exist within the dictionary, so the number and the index happen to go into the dictionary. I move on to the second number, 2. So the difference between 2 to the target is 4. I check to see if 4 exists within the dictionary. It does not. So the number itself, 2, and the index of where it is gets placed in the dictionary. And then the last value that I'm looking at, 4, is going to be the difference between 6 and 4 is 2. I look to see if the difference of 2 exists within the dictionary. It does. I have found my difference. I return the index and the list, or the index within the list. And then I know that this has the index of 2 because I am currently iterating over it. So my solution to this would be 1 and 2. But again, the order doesn't quite matter. It says it can return the answer in any order. So really what we want to solve with this problem, and the pseudocode and the logical steps that it's going to help us solve this problem, is one, iterating through the list. And as we iterate through the list, look at the target number and the number that I'm looking at, calculate the difference, and see if the difference exists within the dictionary. And if it does, I have found my solution. If the difference does not exist, then we enter that number into the dictionary in case it would be a difference for another number. So here we are at our code solution. We're going to be talking about the pseudocode of basically what we just went over within the conceptual problem solving portion of the video. And we're going to translate everything into the code that we need for our solution. So first off is to create a dictionary. You can create a dictionary using curly braces, or you can create a dictionary using this function as well if you wish. Doesn't quite matter. I will keep it as a curly braces. Then I am going to be looping through the numbers within the list. Now, this is going to be an important factor because we want to iterate through the nums list, but I need to have access to the index numbers of the list. So I'm not going to be using the advanced for loop syntax here. I'm going to be just using the range function to iterate through the list so that I know to make sure or have the access to the information of I. So as I'm iterating through the list, again, the whole point of this is to check to see, does the difference exist within the dictionary? So first, to calculate that, I'm going to create a couple of variables here. First is, instead of using nums at I, this code itself might be repeated a couple of times. I want to simplify this and make my code a little bit cleaner. So I'm going to just store that value within the variable numbers. Once I have that, then I can actually calculate the difference by looking at the target, subtracting the number from it, and that would give me the counterpart to what I would need to reach the target value. And then from there, we need to check to see if the difference exists, because again, the whole point of this is if I find the difference of the number that I'm looking at to the target, and that difference exists within the dictionary, then I'll be able to say I found the solution, because the number that I'm currently looking at, which is number, and the difference that is within the dictionary of the difference dictionary would provide me the two values for the solution. So if the difference does exist within the dictionary, again, I have already found, or I have found my solution, and I'll be able to return within a list the value of where the difference is within the dictionary, which is going to give us the index number of where that value exists, and I, which is the index of the number that I'm currently looking at the moment. So if the difference is in the dictionary, I found my solution. The two index numbers are returned to you. If that is not the case, however, that means that I haven't found the counter portion to my number yet. So what I'm going to be doing is then creating that key value pair within the dictionary. So if the difference in the difference dictionary exists, then I return the key, which is I return the value of that key, which is going to be the index number, and the index number that I'm currently iterating through. And if the difference doesn't exist, then I'm going to put a new entry within the difference dictionary where I'm going to store the number as a value and store the index of where that number was within the dictionary to be able to, for the next iteration, see if this number will be the counterpart for another number that we see within the list. To finish off this video, let's talk about the big O notation of my solution. So the big O notation of my solution will be O of n for time and O of n for space. So what I want to do is draw attention to what is exactly making the time of O of n and what's making the space O of n. So our loop that is iterating through the list given to us, that is what's generating our time of O of n. And being the size of the list, whatever the size of the list is, I do have to iterate through the entirety of the list. Worst case scenario, we may find a solution, or worst case scenario, we would iterate through the whole list, or there might be another scenario where we don't have to iterate through the whole list. But either way, we want to consider the worst case of what happens, and it will be O of n. And for space, it'll be O of n as well, because as we are iterating through the list, we are creating a dictionary, and we are going to be filling that dictionary with the numbers that we see within the list. So we are doubling up on the data given to us. We do not necessarily care about the data that is given. We just care about any new data that is created. For us, it is the difference dictionary that is created and may contain the entirety of the numbers list. But that is what's making this current algorithm space O of n. And basically, this is what is taking up the time and space of this solution. You can have a solution where you do not utilize a dictionary, and we can use something called a two-pointer solution to be able to get rid of all of the extra space that we get, and change it to O of 1, but our time, big O notation will go up. And usually in terms of algorithms, it's always going to be a switch off of, if you want your time to be better, then you're going to have to use more space. Or if you would want to use more space, then your time will go down as well. So that is the solution and our big O notation for our two-num problem.